Okay, in this video I'm going to show you how to take derivatives of functions involving the natural exponential function, which is e to the x. The natural exponential function is actually the easiest function to take a derivative of. Its derivative, e to the x prime, is itself. So the derivative of e to the x is e to the x. So for this function we have f of x is minus 6x to the fourth times e to the x. That's a product, so we need to use a product rule. So to refresh your memory what the product rule is, derivative of a product of two functions, g times h, is h times the derivative of g plus g times the derivative of h. So we have two terms. In each term, only one of the two functions being multiplied is being differentiated. The other is left alone. So in this case, well, it was minus 6 out front, and x to the fourth you can think of as our g, and e to the x you can think of as our h. So in this problem, we're going to take the first derivative and second derivative of this function f of x. So for first derivative, I have minus 6 times the derivative of x to the fourth e to the x. And for that, I use the product rule. So I have my second function, e to the x, times the derivative of x to the fourth, which is 4x cubed by the power rule, plus x to the fourth times the derivative of e to the x, but that's just e to the x. So now differentiation is complete. All I need to do is take that minus 6 and distribute it through, and I get minus 6 times 4 is minus 24 x to x cubed e to the x. I could have written it as e to the x cubed, but it's easier to read this way. And then I have minus 6 x to the fourth e to the x. So that is my first derivative. Notice the second term is the same as the original function. That's because the derivative of e to the x is itself. But then the product will produce this additional term. Okay. Now, I'm going to take the second derivative of f of x, but that just means taking the derivative of the first derivative. It's going to be a similar process, again, using the product rule. So first, I should point out, this is also original function. So I can take advantage of my knowledge of this derivative here. So if I have second derivative of f is the same as minus 24 x cubed e to the x minus 6 x to the fourth e to the x prime. So I'm taking the derivative of all of that. Because I have two terms here, I can take the derivative of that individually. And I can also, so I have minus 24 x cubed e to the x prime, and then I have plus minus x to the fourth e to the x prime. And the reason I'm writing it this way is I've just taken the derivative of this. It's right here. So I'm just going to take this. Well, this is my final answer to the first part anyway, so I should box it. So I'm just going to fill that in down here. I don't need to go through a product rule again over the very same thing. And I still need to take the derivative of this part. So if I fill in what I know so far, I have minus 24, and then I need a derivative of x cubed e to the x, which I'll get to in a moment. And then for this part, I'll just fill in what I have here. So minus 24 x cubed e to the x, and then minus 6 x to the fourth e to the x. Okay. So now all that's left to do to take the derivative is take a derivative of this part, x cubed e to the x, which is very similar to what happened up here, but the only difference is it's x cubed rather than x to the fourth. So you can kind of see the pattern. So I have, so I'm going to have x, so if I repeat what I did here, except I'm starting with x cubed instead of x to the fourth, I'm going to have e to the x times the derivative of x cubed now instead of x to the fourth. So derivative of x cubed is going to be 3x squared. And then plus x cubed times the derivative of e to the x, which is e to the x. So I wanted to compare what I have here, when I had x cubed e to the x to take a derivative of, compared to what I had up here, where I take the derivative of x to the fourth times e dx. So we have e to the x times the derivative of whatever power of x, so 3x squared down here, 4x cubed up here, and then that power of x times e dx is the second term. And I still have all this other stuff. Minus 24x cubed e dx minus 6x to the fourth e to dx. Okay, so now I'm going to distribute the minus 24 through all of this. So minus 24 times 3 is minus 72. And then I have x squared e to the x. And then I have minus 24 x cubed e to the x. And then I have minus 24 x cubed e to the x again. And then minus 6 x to the fourth e to the x. So now, to write this in the simplest form possible, I can combine these two like terms, because they both have x cubed e to the x and a coefficient of minus 24. So I have minus 72 x squared e to the x minus 48 x cubed e to the x minus 6 x to the fourth e to the x. And this is my final answer. I should mention that it's no accident that we got these two like terms, because if I were to apply this product rule to take the second derivative, so gh double prime, then that would involve applying the product rule to each of these terms. So for the first term, I'd have g prime h prime plus hg double prime. And then for a second term, applying the product rule to it, I'd have h prime g prime plus g h double prime. And I have, so in each case, I have g prime h prime, and then I have h prime g prime, but they're the same thing. So I have hg double prime plus 2 h prime g prime plus g h double prime g. So this is the product rule to compute the second derivative of a function that's a product. So we get three terms. Really, well, it's four, but then two terms are the same, so they combine, and we get a coefficient of 2. So in a problem where you have to compute the second derivative of a product, you could use this to jump to that directly, bypassing the first derivative. You just need the first and second derivatives of the individual pieces. So that might be a